to the Truth in My Days podcast, where we defend the Word of God against the challenges of men.
Hi, I'm Dana Torse, and welcome to another episode of the Truth in My Days radio program. Today, I'm here with John Torse and Jason Chan as they discuss the important topic of creation and evolution. We are continuing from the previous episode. We hope you enjoy.
They actually have top three facts, evidence for the Big Bang. They point to number one, the so-called background radiation, the cosmic background radiation. And they say, well, where did this radiation come from? It fills the universe uniformly. They'll tell you there's the super cooled afterglow from the original Big Bang. Sound reasonable?
I'm not sure what that means.
Well, where's this radiation? Because you have this big burst of energy with this expansion. And so that burst of energy left this track because it's cooling, but it's not all gone.
Okay.
So you have that background heat, basically. And the temperature of the universe is not zero, it's above zero. And that's where it came from. It's a super cooled afterglow from the original Big Bang. Okay? That's evidence number one. Is it, though? Cosmic microwave background radiation proves that there's cosmic microwave background radiation. It doesn't prove that it's the super cooled afterglow from the original Big Bang.
Right.
Before the Big Bang model was even invented, there were scientists who said, look, you have stars in the universe. Stars give off heat.
Yeah.
So you're going to get a certain minimum background radiation. So just having background radiation is not the super cooled afterglow from the original Big Bang. That's an assumption. They're basically jerry-rigging it into their model, but it doesn't actually prove it.
Okay.
Any evidence that can be legitimately interpreted more than one way is not evidence for anything, right?
Right.
If I have like three suspects for the killers, and I find that the killer was left-handed, and Tom there's left-handed, it proves he's a killer, right?
No, not necessarily.
Well, especially now if Dick is also left-handed and Harry is also left-handed.
Right.
So here's the problem. The cosmic background radiation only shows that there's cosmic background radiation. There's no evidentiary basis for saying it as the super cooled afterglow from the original Big Bang. So that actually is not evidence.
Okay.
The second one, and this was the biggie, was that the universe is expanding. It tells that galaxies outside the Milky Way move away from us at a rate proportional to their distance from us, pointing to continual expansion from a single source. And we'll look at that in detail later.
Okay.
And the third evidence that they will give you is the Big Bang nucleosynthesis. And what this is, where do you get the heavy elements? Okay, that was one of the problems. How do you get heavy elements in the universe?
Sure.
And they say, okay, the Big Bang theory predicts that the earliest atoms to emerge from the dense particles superhydrogen and helium, because those are the two simplest, lightest weight elements.
Sure.
And they say, so most of the elements in the universe are hydrogen and helium, and the ratio is 3-1. Roughly 75% hydrogen, 25% helium, and then trace amounts of the other things. And they would tell you that using powerful telescopes and spectrometers, cosmologists confirm that the observed universe is 74% hydrogen, 25% helium, and 1% heavier elements. Sound good?
Is it really?
It is, as far as we can tell. Those measurements are pretty accurate.
Okay.
The problem, as we will see when we get into this, is that that's not what the Big Bang Theory predicted.
Oh.
This is a retrodiction.
Interesting. Okay.
So that's what we're looking at is the three evidences for the Big Bang. So as we say, there's the fact that the background, cosmic background radiation, the expanding universe, and the Big Bang nucleosynthesis. These were the three kind of linchpin arguments for the Big Bang originally. So let's look at some of these and see, do they really demonstrate the Big Bang? The cosmic background radiation, and we've touched on this before, the problem with cosmic background radiation is it's uniform in its level. It's 3 kelvins or so everywhere you look. Now, early astronomers said there would be a certain background radiation just because you have stars out there and they're giving off heat. You are going to have a certain kind of background radiation, and what we find actually is consistent with that. So there's no reason to see it as anything other than heat from the suns. In fact, the Big Bang Theory didn't predict that there would be a cosmic background radiation left over from the supposed expansion of the Big Bang. Sir Arthur Eddington, as I said, he predicted that there would be a starlight background radiation of about 3.2 kelvins, and he predicted that in 1926 before there was a Big Bang Theory at all. So when the Big Bang Theory came along, they had different estimates. They would have to have extra radiation in addition to that, and their radiation estimates ranged anywhere from 5 up to 50 kelvins.
I see.
And they sent up this, what's called the Cosmic Background Explorer satellite, the COBE, back in 1989. And it was supposed to measure fluctuations in the cosmic background radiation. What we measured to that point was this absolutely smooth background radiation of 3 kelvins, which matched what Eddington had predicted without the Big Bang. But if it's so smooth, where do you get the fluctuations that would give you galaxy formation? If it's same everywhere, you're not going to be able to get any place where you get an accretion of materials. Okay. It would have to be different in some places. So as I said, in 1989, they sent up this Cosmic Background Explorer. It's called COBE, CO for Cosmic, B for Background, E for Explorer. And they found fluctuations. And this was announced to great fanfare in 1992. I remember this. It's all over. Maclean's magazine ran a cover article with a big headline, "Looking at God. Scientists proclaim that space images show the origins of the universe." And then in Newsweek, their headline is "The Handwriting of God. A satellite spies the ripples of the Big Bang." It's a general rule of thumb, by the way. The wilder, the more grandiose the claims, generally the less substance there is to it. And I start talking about looking at God and so on, you know that they're really overstating what's there.
Yeah, the media usually does sensationalize things.
Indeed they do. Now, if we look at something a little more restrained, Scientific American in their July 1992 issue, their front page, cover headline was "More Proof for the Big Bang." And then they show this picture. It's sort of like an oblate spheroid in blue with big orange patches all over it. And under it, it says the COBE sky map shows telltale fluctuations in the temperature of the early cosmos. Now, it's a good thing they tell you what this picture is, because your average reader looking at this would have no idea what it's even supposed to be. Mm-hmm. But you look at it, you see this blue oblate spheroid, and you see all these orange patches, big orange patches covering probably at least half the volume or more. Who's going to argue with that? They don't even know what it is.
Yeah.
What is it? Well, the orange areas are supposed to be the different temperatures. And you look at all those patches, sure, there must be enough to explain galaxy formation, right?
Possibly.
Yeah, case closed, you would think. Then you look inside the cover and you look at where they explain what it is. This cover image shows the sky through the microwave-sensitive eyes of the Cosmic Background Explorer satellite. Orange indicates warmer than average regions. Blue shows cooler than average ones. Temperature variations are thought to trace the uneven distribution of matter shortly after the formation of the universe. Well, that's what you need, right? Mm-hmm. But you read a little further. This is a little box on the top of page 6. It says, most of the features seen here are instrument artifacts, however.
Wow.
What does that mean?
That means it's not actually there aren't actually fluctuations in the universe. It's actually just fluctuations in the camera gear itself.
Exactly. The actual anisotropies that they measured, the ones that are actually in the background, just they're too small to be seen.
What? Okay.
They were actually below the detection limits of the instruments.
Yikes.
So, but the picture you get on the cover sure makes it look like, hey, game over. In fact, the fluctuations were far too small to explain galaxy formation. Far too small. And it was not what the theory had predicted. So you're starting to get in a problem. It's the article, the one from Newsweek, that talked about the handwriting of God. It actually admits in the article that says these variations are not what's needed for galaxy formation. It's far too small for that. What Kobe actually found was that the large-scale anisotropies needed for, and that means difference in temperatures, needed for galaxy formation aren't there. They're not there, which would mean the Big Bang Theory is wrong. But that's all hidden. What the general public hears is, hey, we've seen God, we've seen the origin of the universe, we have proof for the Big Bang. Yeah, but the scientists know. McGuff in Astrophysics Journal writes, cosmic microwave background is very smooth. Structure cannot grow gravitationally to the rich extent seen today without leaving indiscriminately large fingerprints on the microwave background. And Hartnett adds, the large fingerprints are just not observed. And it gets worse for them. It gets worse. The Big Bang Theory would require a random distribution of galaxies throughout the universe. But that's not what we found. It began to find these clusters of galaxies. Galaxies are arranged in a very specific pattern of galaxies.
Sorry, before we continue, why would we expect a random distribution of galaxies?
Because the original Big Bang, all of the matter energy is inside this tiny little singularity, which then suddenly expands. Mm-hmm. And so matter is thrown out in all directions randomly. Mm-hmm. There's no pattern to it.
Right.
So the chance of having accretion at any point is just randomly distributed.
Right. Okay.
So you should have that random distribution, but that's not what they found. And it led to a crisis internally, a crisis in 1986. Okay? Dwayne Gish of the ICR does a good write-up on this. And as he tells us, a fellow called Tully from the University of Hawaii demonstrated that there were ribbons of superclusters of galaxies 300 million light years long and 100 million light years thick, stretching out about 1 billion light years and separated by voids about 300 million light years across.
Thank you, everyone, for listening today. Unfortunately, we have run out of time, but please join us for the next part tomorrow. Same time and same place. If you enjoy our content and think this is important material, the best compliment you can pay is by sharing this with your friends and family. This helps us out a lot. Also, if you enjoyed today's program, please like, comment, share, and subscribe to this podcast. We would love to hear from you. Thank you for listening to the Truth in My Days podcast with John Torse. We would love to hear from you. Please feel free to share any questions or comments you may have. You can reach us on Facebook, Instagram, MeWe, and YouTube. Simply search Truth in My Days as one word. Again, Truth in My Days as one word, no spaces in between. And you can connect with us. You may also visit our website for more comprehensive material and to learn more about our ministry. Our website is truthinmydays.com. Thank you.